If we fine with 13A trigonometry, then these first few slides you don't really need to know. It's probably nice to know, but for the sake of the exercise, you're not really dealing with the understanding about trigonometric ratios. But if you're interested, it all starts with a unit circle. Okay, everything that you know, trig ratios, they all come back to a unit circle. And unit circle basically means that you have a circle, unit meaning 1, so that implies that you have a radius of 1 unit. Now that could be 1 centimeter, could be 1 meter, could be whatever it is, but it's 1 unit. So in a unit circle, if I asked you the circumference of a circle, which goes back to year 7 and 8, technically 8, what's the circumference of a circle again? 2 pi r. Okay, so you say, all right, well, that's the perimeter of a circle, which is given by the outside length, which is given by pi times d, or 2 times pi times r, because twice your radius is your diameter. And this will tell you the distance around the circle. Okay? And if our case is that it's a 1 unit length, then that will tell us that in a 360 degrees circle, we can say by ratio that the degrees is equivalent to 2 times pi times 1, which is 2 pi, but what you need to understand is this is a measurement of length around the circle. This is the measurement of degrees. It's an angle. They're different. Okay, so this might help you later on if you were to understand the concept, why you change radians to degrees and what does it mean to keep it in radians. You're talking about the arc or distance of a circle. That's what you're really doing. Whereas opposed to solving the angle that it makes. Okay? Now, for every circle, the nice thing is you can always draw to the point on a circle and then you draw a perpendicular line down, and that gives you a right angle triangle, which is where your soccer toe is coming from. Okay, so sine, cosine, tan, it all comes from this idea of a triangle. You got your hypotenuse, which is actually your radius. Okay, and you got your opposite, and you got your adjacent, a 90-degree angle. That's where it's all coming from. But I'm not going to go through that today. You'll probably encounter that in methods, and someone will teach you that. Okay, but here we go. Defining sine, cosine. It's healthy to sort of understand that concept so that you don't confuse yourself what sin of theta really means and what cosine of theta really means. Okay, the way I sort of, just to start you off into understanding it on a very brief point, cosine will represent your x values. So cosine of an angle represents x coordinates or x values, and your y values can be represented with sine of theta, which is y values. So an example is something like this. If I gave you this, right? And I asked you the angle for a right-angled, what is the angle there for a right angle? 90 degrees, okay? So if I then said, what is sine of an angle? And I say sine of 90 degrees in a unit circle. You see, in a unit circle, we've got a height here. And it's talking about, remember, we're talking about the length around the circle. When we say sine of 90 degrees, remember I said sine represents your y values. It's just asking, if I'm going around the circle, sine of 90 degrees, what is my y value at that point when it makes 90 degrees? And logically, this coordinate here would be 0, 1. And so that tells me the y coordinate, which is 1. That's why we know sine of 90 degrees, if you type that in your calculator, the answer is 1. Okay? And this is sort of where it sort of just wants to define what sine is and cosine is. But just to keep it short and easy, every time you say like sine of 0, for example, you can say sine of 0 degrees, and you just think about it. All right, 0 degrees is here. So this is where I am on the circle, right there. That's 0 degrees. If I want to ask what my y values are, looking at that coordinate, I know the distance is 1. This is 1, 0, so the y coordinate is 0. So I know sine of 0 must be 0. I can do the same for sine of 180. See, if I look at sine of 180 degrees, see, if I know it's a unit circle, that's a length of 1. The coordinates there would be -1, 0, and sine represents your y values, so it's also 0. Okay, so this just helps you to understand what it means when you say sine of 30, sine of 40, sine of 45. You're just going around the circle. Okay, now, why am I sort of going through that is because then the question is, why is sine the y values? So why is sine the y values? And why is cosine the x values? Just to start off by definition, if this is my triangle, that's my triangle there, angle theta makes 90 degrees. Naturally, if I know that the radius is 1, and this is opposite and that's adjacent, then let's say this is 30 degrees, hypothetically, then you'd say sine of 30 is equal to opposite over hypotenuse. True? Then that would be opposite over hypotenuse, which is 1, because you've got a radius of 1. That just tells me O. So that's why when you say sine of 30 degrees, O is just your y value. It's how high it is. It's the height. Every time you're going around the circle at that point right there, it's just the y value. O represents the y values. That's why sine becomes y, and cosine, which is adjacent would be here. That's why it represents your x values. That's why we naturally tell you, we say cosine represents x values and sine values represent your y values. Then that's all you really need to understand up until this point. In methods, you'll understand more about the graphs and whatnot. But that's what they're really trying to say here. Okay, and that's what they're trying to represent. If you happen to look at the definition in your textbook, you're like, why did they change it to cos theta and sine theta? It's because they're just saying this is x values and y values. That's the logic. Okay, and the logic comes from unit circle, radius of 1, circumference gives you 2 pi. That's where it's all coming from. Okay, but anyways, having said that, once you understand the ratios, then you got your 3 ratios that you learnt in year 9. Then your SOHCAHTOA, okay, and that all comes from your right angle triangle by definition, and then you would have done this to solve. Yeah, so that's what you did yesterday, and I'm assuming most of you were fine. Yeah, okay, just to quickly do it, I'm just going to show you the method. This is your angle, so opposite, this is adjacent, so you have to use tan. And so that must be tan of your angle equals to opposite over adjacent. You can say then tan 20.16 equals to x over 8. Therefore, x must equal to 8 times whatever tan of 20.16 is. Okay, that's just for the people who are watching the video again, in case they don't know. And you type that in your calculator and you solve. Okay, so that's 13A. Now, let's go to 13B. 13A and everything you learnt in year 9 and a bit of year 10 has been for right angle triangles. The things that I've drawn were all right angle triangles, 90-degree angles. What you're learning now, sine rule, cosine rule, in this chapter is for non-right angle triangles. Okay, so this only applies to non-right angle triangles. And you can memorize this if you want. I personally don't really care. I just look at the problem and see what can I solve with the tools I have. But those are your tips. When you use sine rule, when you have one side and 2 angles that are given, when you have 2 sides and a non-included angle are given, that's when you use the sine rule. But to me, you can sort of judge by looking at a triangle and you can figure it out. But if you like rules and you like steps and you like a method, those are your 2 tips when you use sine rule. Okay? Now let's take this triangle. What is the sine rule? And I'm going to take you through to see where the rule comes from. That's a non-right angle triangle right there. Okay, so if you imagine that I didn't have that height, that 90-degree height there, you've got a non-right angle triangle. And I called these corners A, B, and C. We normally capitalize or make it capital letters for angles. So this angle here would be angle C. This angle here represents angle A, and this is angle B. If you remember back in year 7 and 8, how you normally denote angles is you do angle, and you do ACB, and that represents that C is the angle you're talking about. That's why capital letters represent your angles. Okay, so we're like, okay, if we want to talk about this angle here, it's angle ACB. So C being in the center, that's the angle I'm talking about. If I want to talk about angle A, I'll say angle, I don't know, CAB. As long as A, or the angle you're looking for, is in the center, that's the angle you're talking about. Okay, now, so let's break this apart. The only things we know up until this point, year 9, right angle triangles, that's all we know. So that's the reason why I made a perpendicular line. I cut down from the corner C, and went down perpendicularly with AB, this makes a 90 degree. Now, logically, you could also do the same for A. You can do that, and it will make a 90 degree angle. You can do that too. Okay, and this is where the rules are coming from. I'm saying if I did this, and then I had a look at triangle A, C, D. I'm going to draw it for you so you can see. I'm going to color it in. So A, C, D. It's a right angle triangle. Okay, so that's my right angle triangle. I'm going to draw it again. A, C, D. And let's say this is length B. We normally denote it opposite to the angle. So if this is angle B, opposite to that is length B. If this is angle A, this is length little a. Okay, that's how we denote it. And we say if this is angle C, opposite to angle C would be length C. Okay? Now, so what they're saying is, all right, if this is B, little b is the length of B, and this is a height that we don't know, and we don't know what that length is. But we know in right angle triangles, you only need two sides. Cyclotol only ever needs two sides to solve. So what we're going to do is we're going to rewrite H. We're going to write H in terms of an angle. And the nice thing we know, whoops, I'm going to draw it again. Nice thing we know, this is H and this is B. If this is the angle A, so this is the angle A, we can say that sine of the angle A, which is opposite over hypotenuse, our hypotenuse is B. Whoops. Our hypotenuse is B, and our opposite is our height. So I can rewrite that and say it's H over B. Okay? And if you've got H over B, that means I can rewrite the equation by multiplying B on both sides. You have B times sine of A equals H. Fair call? Yeah? Okay, so that's one way to look at it. Let's look at it another way. I could also talk about this triangle. I can say, all right, let's say if I wasn't talking about that triangle, I can also say, let's look at BCD, because that's a right angle triangle. I can draw that. There you go. Same deal again. If this is your right angle triangle, and you got B, C, D, and this is the length of A, that's a right angle, and that's still H, you can use the same thing. If this is angle B, I can say sine of the angle B is equal to opposite over hypotenuse. So you got H of A. And conveniently, this is what you get. H will equal to multiplying A on both sides, A times sine B. But if these two are equal to each other, because they're both H's and they're both the same height, then I can also say this then. I can now say, if they both have the same height, I can equate it. I'm going to say A times sine B, which is over here. Sorry. I'm just saying A times sine B should be equal to B times sine A. They should be the same length. If they're the same length, then at this step here, I can say, oh, well, how about I just collect all the A's together and collect all the B's together? So I say, let's divide this side by sine B. So it cancels out. And then divide this by sine B. That's where you're getting B over sine B times sine of A. Okay? If you want to remove the sine of A on the right-hand side, well, just divide by sine A. And divide this by sine A. And suddenly, you got yourself the first two parts of the rule, sine A, or little a over sine A equals to little b over sine B. If you're wondering where the C comes from, if you do exactly the same, you just split it this way, and then you looked at this right angle triangle, and you use the same lengths, then you'll get C. So, I know I could have just gone to this straight here and just said, memorize that rule. I didn't want you to memorize. I want you to see the steps and progress in what you've been doing. Year 9 mathematics allows you to do right angle triangles. You can split a non-right angle triangle into right angle triangles to find out non-right angle triangles. Is what you're really doing. Okay? So right here, what's the rule that you need to learn for this exercise 13b? Little a, which represents the length of A. Length of A divided by sine of the angle A is the same as the angle B, or length B, divided by the angle B. That's what I'm saying. So this whole thing is just saying length of A, angle of A. and that's your sine rule. It's one of the easier ones to remember because it's the same thing. So little a over sine big A, little b over sine big B, little c over sine big C. They're all equal to each other by ratio. Okay? Now you're wondering, okay, so why do I need to know that? It's because now if you have two sides and an angle, you can figure out the other side or the other angle. Okay, so I'll give you an example. Let's have a look at an example. Let's say this one. Okay? I've got corners A, B, C. They've given me angle C. So angle C equals 31. Opposite to that angle is little c. So I don't know what the length of little c is. I have no idea what the length is. Whoops. Oh. Okay. But they did give me angle B. So I got angle B equals 70. But I also know opposite to that angle is 10. So little b is 10. So that's what I know so far. I know that big B is 70, little b is 10. I've got big C, but I don't have little c. So, according to the formula, I can use that part. I got the b's. I got part of the c's. I can sub it in. I can say, all right, well, c I don't know. Little c I don't know. But I know the big C. So sine on big C, which is sine of 31. That's meant to be equivalent to little b divided by sine big B. Okay? And so, there you go. If you just multiply both sides now by sine 31. Okay, so if you multiply both sides by sine 31, and that allows you to figure out the length of C in a non-right angle triangle using the sine rule. So how's that feel? Easy? Yeah? Okay, so little a, little b, big A, big B. Yeah? Let's try this one. Same concept, but I want you to think about it though. So you're going to use a calculator, get the answer, but I want you to think about why you have to look at the diagram before you make a decision, okay? Have a go with this one, same drill. You got your y, you got your x, your z. I want you to use sine rule and figure out the length, where is it? Find the magnitude of x, z, y. So they're asking you to find out this angle here. Okay, so I want you to find the angle z. What does the angle z equal to? Using the same method just before, it takes about 3 steps. Use a calculator. Whatever your answer is, I want you to think about it. Is it right or is it wrong? So I want you to think about z, angle z. Give you about 3 minutes and then I'll get you on to exercise 13B to work. Do I have you guys on Wednesdays? Or is it Thursdays? We'll go through the test on Thursdays then. And bring in your calculator on Thursday. I've got to teach you how to use a CAS calc. Just for those who are stuck on that first step that I gave to you, I've just subbed all the values in for little x, big X, and little y, big Y. And if you're wondering how to get z, because it's a denominator, it is okay to do this. To flip the top and bottom, the reciprocal, because remember, whatever you do to the right, as long as you do to the left, it's fine. So if it's easier, you can do it that way. Okay, it's perfectly fine, nothing wrong with that.
So why can't you just flip it?
Because it's like saying if I had 3 equals 3, is that true?
Yes.
Okay, so is this the same as the above?
Yeah.
Okay, if I decided to just flip.
No, that's not it.
So this would be like this, is this the same?
Oh, so if you like flip both of them, you're...
Mm-hmm. That's why whatever you do to one side, you can do the other.
Oh,
So desu ne. Alright, just in case you've solved it, times 6 on both sides, and solve this on your calculator, And you get this, but the question asks you for the magnitude of the angle. This only tells you the distance around the circle. That's 0.5, tells you distance or the height. It doesn't tell you the angle. So you have to sine inverse both sides in your calculator. So sine inverse, whatever this is. If you do that, what's your angle? Check your calculator, I want to know. Because then I want you to think about it. What's the sine inverse of 0.5071? Around 30 degrees. Now, whatever your answer is, especially in special methods later on, look at your answer and then compare it to the diagram. Does Z look like 30 degrees? No. It looks more than 90 degrees right there. But it's less than 180. So this is where it gets interesting because you told me it's about 30 degrees-ish. But that doesn't look like 30 degrees. So now I've got to figure out another angle that is equivalent to that height. The answer is you're going to take 180 minus that angle. And I don't want you to just memorize, why is it 180 minus that angle? Because you would have got 30 something. But 30 something doesn't actually make sense. Why did I do 180 minus 30 degrees 0.47 is the question. Yes, Jamie? Perfect. Now, let's just stop here. Let's just draw the diagram, okay? We said 30 degrees. I want to draw the diagram because we talked about a unit circle. I said sine of an angle, okay, and we just figured out that was 30 degrees to give you 0.5. But what was sine representing? Y values. So let's say 30 degrees, if I drew it like this, let's say that was 30 degrees. At this point, I have an x and a y coordinate. What you just solved here is the y coordinate at that point. You just figured out that this point, whatever x is, I don't know what x is, but I do know y is 0.5707. That's the height. Because remember, unit circle has a length of 1. So when you say 0.5071, you're just talking about it's just a bit above half. That's the height. That's what you just worked out. What they're asking now is, if we know it can't be 30 degrees, where else around the circle will you have a height or a y value of 0.5071? Well, you just look at the y value. If this is y value here, well, if this point has the same height, then obviously if I keep going across over here, that would also have the same height. So that means if I draw the same triangle, if this was 30 degrees, then this would also have to be 30 degrees. So if that's 30 degrees, that's 30 degrees. That has a height of 0.5071. Then this one should also have a height of 0.5071. The question is, what's that angle? See, if I know it's 30 here, and if I know all the way is 180, then what's the angle to find from here to here? So logically, if you know all the way here is 180, 180 minus 30 will give you that angle there. And that's what I did in the next step. Hi.
So 19 and 0.
So that's what I'm doing. I'm just saying 180 degrees, subtract that same angle will give me the angle I want. Now I know this is confusing because it is part of methods and you guys haven't reached there yet. But that's why I wanted you to understand unit circle. Okay? Yes, Dajan. Magnitude is size. So value. That's another way of thinking about it. It's a value of something. It's a value of a distance. So for example, if I said this is up direction and downwards direction. If I said I went 3 up, 1, 2, 3, okay? And I said 3 back down, 1, 2, 3. So it was 3 up, 3 down. How many steps have I taken? 6, okay? Now position-wise, I said positive 3, but going backwards is negative 3. Yeah, so up 3, and then plus a negative 3. So positive 3 plus a negative 3 gives you what? Which is not a magnitude. See, 0 is a position. It's a direction. So we call that not a magnitude. When we say magnitude, we're talking about the actual length, the actual value. And in our case, I walked 6 steps. I didn't walk 0, I did walk, but position-wise, Seems like I didn't walk. Position-wise, relative to where I started, it's 0. But the amount of steps I've taken, that's the magnitude. Magnitude tells me I've done 6. That's the difference. So when we're working with sines, it tells you a direction. It doesn't necessarily tell you distance. So if I went up 3 and then went back 12 and went back 3, you only know the position where I was from the origin, but you don't know how far I've actually gone unless you count the point. And that's what you just did. You counted 3 and then 3, and that's why you know it's 6. That's the difference between the two. Yeah. All right. That might take a while to sink in. It's okay. Look at the answers in the back and try to think about this. I'll talk more about it, or maybe you'll get more of it when you get to methods. There will be more emphasized about symmetry of unit circles. Okay? But for now, all I want you to do is just use sine rule, try to figure out the sides. Don't worry too much if you're getting the angles wrong. Okay? If you type in sine of that angle and it gives you exactly the same value, you're doing all right. Okay? It's just that the understanding of unit circle might take a while, not until you actually get there. Okay, so for now, learn the sine rule. Little a on big A. So sine big A, little b on sine big B, little c on sine big C. That's your sine rule. Okay? And if you still don't understand that angle thing, you can ask me and I'll come around and try to explain it another way.